In our last section in Chapter 4 for Algebra 2, we're going to look at Section 4.5, which is all about solving rational equations. Before we get started, let's take a look at this example to start. It says Nikki and Tevon use different methods to solve the equation 1/2 x plus 2/5 equals 9/10. So for part A, I want you to pause the video and look at their two different strategies and see the advantages and disadvantages of both. And then for part B, I want you to explain if they're correct or not. Okay, so hopefully as you looked at it, what you saw is that Nikki decided just to move the fractions to the other side, found a like term, or found a common denominator, and then solved for x. Okay, so she kept the fractions in there. Tevon, you can see he decided to do this strategy of clearing the fraction. So he multiplied both sides by the least common denominator. What happened when he did that is that it cleared all of those fractions, so he just is left with 5x plus 4 equals 9 to solve. Okay, so yes, actually both of these are okay. So did they use a correct method? Yes, they're both okay. And in terms of advantages or disadvantages, the disadvantage of the first one is you still have fractions. Okay, so I guess I don't know exactly advantages versus disadvantages, but for me personally, I prefer Tevon's method just because anytime I cannot deal with fractions, I prefer not to. Having said that, with basic numbers like these, it's not too bad, but in some of the problems we're going to look at today, you're going to see how complicated it can get. So I am going to focus mostly on the strategy of clearing the fractions like Tevon. So first, before we start, I want you to write down that a rational equation is an equation that contains a rational expression. Okay, so the difference with what we're talking about today versus what we've been seeing is now it's got the equal sign in it. So our job is to solve for x in these problems. And again, we are going to use the strategy that Tevon did. And that means we are going to multiply both sides by the least common denominator, okay, which we practiced figuring out last class period or in section 4 when we were adding and subtracting fractions. Now, today's examples will be very, very basic because we're just understanding the idea of how to get rid of the fraction, and then tomorrow we'll start adding in more fractions. So when I look at these two sides, it's like a 2 over 1 on the right, and so the only factor that I see is x plus 4. So I'm going to multiply both sides by x plus 4. And remember, oops, if I multiply both sides by that, basically it's like by x plus 4 over 1. I'm not going to show that every time. But so what that means is that as I multiply a fraction by something, I'm distributing that just to the top. So if I wanted to show my work, I would do 1 times x plus 4 on top. That's this x plus 4, but it's still divided by the x plus 4 that was already there. Then it equals 2 times that x plus 4. That one was just over 1. I would not have to write the over 1. So here's what's going to happen if you did this correctly. Step 1, you're going to multiply both sides by the LCD. You can show the step that I just showed. You don't need to. But then you're going to simplify each fraction if you showed the work that I did. Some of you, as time goes on, you'll be able to kind of understand that these cancel. And so you would have canceled them in your head. The 1 doesn't matter. So I'm just going to go 2x plus 8, distribute that. And then you're just going to solve for x. Okay, so I'm going to subtract 8 in this case, get negative 7 equals 2x, and divide by 2. So I get x equals negative 7/2, which is actually my final answer. Okay, so that's the strategy we're using today. Multiply both sides by the least common denominator, distribute that to the top of every fraction, cancel and simplify in each individual fraction, and then solve for x. So here's another example. If I have 1 over x minus 3 equals 5, again, it's like a 5 over 1. So my LCD is x minus 3, so I multiply both sides by x minus 3. Again, I would multiply both tops by that, so 1 times x minus 3 over x minus 3 equals 5 times x minus 3 over 1. Again, typically I don't show the over 1. These cancel. I get 1 equals 5x minus 15. Add 15 to both sides. 16 equals 5x and divide by 5. So x equals 16 fifths. All right, on the next slide, I want you to pause the video and try these two on your own. After you've practiced them, come on back to the video and check your work. So hopefully you recognize that the first one you multiply by x plus 5, you'll see that I showed my work a little bit differently because there was only a single fraction. I realized I could just cancel the x plus 5 right away. So I got 2 equals 4x plus 20, subtracted 20, and divided by 4. So x is negative 18 fourths, which simplifies to negative 9 halves. Both the top and bottom divide by 2. Make sure you reduce your fractions. The second one, I recognize that I can multiply both sides by x minus 7. You can see how I showed my work a little bit differently there. That's how I would normally think about it. But when things get more complicated tomorrow, sometimes students need to write it out or prefer to write it out the way that I showed in the other examples. So the x minus 7 cancels out on the left side, so I get 1 equals, and then I multiply by x minus 7 on the right. So I get 2x minus 14, add 14 and divide by 2, and I get 15 halves, which I can't reduce. Okay, so that's really the skill we want to be able to do from today. So I know it's fairly basic, but now let's look at it in a little bit. We'll start to introduce a little bit higher level in this word problem. Okay, so this word problem is just to follow along with. We're going to do a few word problems, one today and one tomorrow, where we're starting to talk about these work rate problems. And so it says Arthur and Cheyenne paint a wall in 6 hours when working together. Okay, so they're working together and they paint it in 6 hours. Cheyenne works twice as fast as Arthur, so that's going to be important. And how long would it take them to paint the wall if she were to work alone? Okay, so first I'm going to use that x is the number of hours to paint the wall. And then the one thing we're going to need to know, both for this example and the little bit more complex one, no, I guess that was something else. But here we go. So what we're going to do for this is I'm going to think of what I need to write as my Arthur expression. Okay, and what I know is that he could paint one wall in 6 hours. Okay, so he paints, one wall in X hours, not 6. Okay, because the only information that they give me is that Arthur and Cheyenne works twice as fast. So she can paint 2 walls in X hours. So I just picked the 1 for Arthur. Okay, so I just said, okay, if he can paint 1 wall in X hours, then she can paint 2 because she works twice as fast. But if he can paint 1 wall in X hours, I actually need to be able to write that as an expression. Sometimes it's a little hard to see it, so before I do that, I'm actually going to write the expression for what they can do together. Okay? It tells me that they can paint 1 wall in 6 hours. Okay, so as a sentence, it's 1 wall in 6 hours. But if I want to write an equation or an expression for how much of a wall in 1 hour, okay, so the expression for how much of a wall they can paint in 1 hour together, well, if they paint 1 wall in 6 hours, then they actually can paint 1/6 of a wall in 1 hour. Okay, so this is the part that's a little confusing, is understanding how we take this statement and turn it into the 1/6. But it's because we're actually writing an expression for how much they paint in 1 hour. So they can paint 1/6 of a wall in 1 hour. The reason I started there is because now I have the same wording in the 2 above. So if I can paint 1 wall in 6 hours, and that's 1/6, then 1 wall in X hours would be 1 over X. Okay, so 1 over X of a wall in 1 hour for Arthur. And then for Cheyenne, it would be 2 over X. So 2 over X of a wall in 1 hour. Okay, and so the reason we do that is because now we can take Arthur plus Cheyenne And that should be equal to the 1 over 6. Okay, so the 1 over 6 is when they work together. These would be if they're working individually. And ultimately, we're trying to figure out if they work individually. Now that I've set up the equation, which again, you don't need to worry about too much. I do just like to show you these different word problems, but from this section, really, we're focusing more on the skill, but this is a real world application. Okay, so now that I have that though, I need to find my LCD. Well, if I look at x, x, and 6, the LCD is actually 6x. So I do want you to focus on this math. Okay, the difference is that now I am going to multiply both sides by 6x. So it's going to turn out just slightly different. Remember, step 1 was multiply both sides by the least common denominator. Step 2 was to multiply all the fractions by it. So if I multiply this first fraction, I get 6x over x, but I also need to make sure I multiply the second fraction. So I get 6 times 2x over x equals, and then this is 6x over 6. Okay, and then we said once we did that, we're going to simplify each fraction. The x's cancel here, the x's cancel here, and the 6 cancels here. So I get 6 plus 12 equals x, so x equals 18. And remember, 18 is the number of hours to paint the wall. So when they work together, it takes them 18 hours to paint the wall. What that means is that, or sorry, that's not what they get working together. That's this x. So Arthur can paint one wall in 18 hours. Okay, but they actually wanted to know Cheyenne. So remember, Cheyenne was 2 over x. So, or she can paint 2 walls in x hours. So 2 over x equals 18. So I'd get 2 equals 18x, so x equals 9. So it takes Cheyenne 9 hours is the final answer. Okay, so there's some pieces of that are a little weird and hard to understand in terms of writing the expressions and understanding the interpretation of it. But what I want to make sure you're able to do from this section is, if you had been given this equation right away, being able to understand that you multiply both sides by 6x and then simplify from there. Okay, and that's actually a little bit of a lead-in to tomorrow. Today's homework will focus more on the very basic where you just have a single fraction on both sides. Tomorrow we'll get more into this situation where we're adding fractions on a side. All right, that's actually all we have for today. So it's a little bit shorter video, which is nice. And your homework, again, if you understand this idea of clearing the fractions, should go pretty smoothly for you. So go ahead and work on your 4 or 5 day 1 homework. And then we'll see you tomorrow for the little bit higher level problems along these lines. Thanks.